Hi, everybody, and welcome along to Programming Fundamentals, Week 3, Talk B. If you're joining us live today, please give us a thumbs up in Slack, where I've just posted. Okay. So let's get started straight away. In our last class, we were looking at methods, and we looked at the signature of a method. So we've been using methods for quite some time. But the signature hadn't been described and the body hadn't been described. So we actually just went into some terminology there. So we're looking at the return type, the signature name, and also the parameters. We also looked at the body, which is the statements that are executed when you implement or call a method. And we looked at the distinction between calling a method and defining a method. So up to now, we've been writing lots and lots of calling lots and lots of methods within processing with mouse events, drawing shapes, changing colors. We were calling methods to do that. We also defined some methods. We defined setup and draw several times, but now we moved on to defining methods to do specific tasks. And we got into some examples, and I asked you to take a look at some additional examples before today's class, which were I's and X's. So we can see here, these are the cards that we asked you to work through, and the labs, which I've seen people have been working through those, and everything seems to be going okay. But we had some additional cards which I made available after class, immediately after class, and they were examples for calling I's and also for drawing X's. So I'm going to do a quick recap on those, but I'm not going to go into them in detail, as you can find videos to go with those on our tutor's site. And I might just switch to there, take a look at that. So this is 3A, last week, the class from the last day. And just what I want to highlight is that we made available these 3 cards after class with play buttons on them to take you through explaining in detail the I's example and also the X's example. Okay, so if you haven't seen those, you might take the time to go through those, catch up later. Okay, today then we move on. And we are looking at methods, writing more of our own methods. So I'm going to build on those I examples, and I'm going to do some revision by way of working through an additional example called iGrid. For those of you that collect your notes on a Sunday night, I've just added these last night, so you may want to download these slides again. There's a couple of additional examples here. We'll also go through returning a value from a method. So getting a method to work out some number and send it back to us. Celsius to Fahrenheit. And we'll look at some more examples of those. So I'm moving it on today. We'll look at product, how to calculate the product of two numbers, how to take in a number and return its cubed value. So itself multiplied by itself multiplied by itself. And this should really make it clear then what we are doing when we return a value from a method. So we're continuing on with methods today. And I thought this might be a good place to introduce some debugging for you. So I'm going to introduce you to the processing debugger today, just very, very quickly. We're not going to spend much time on it, but it will help you understand what's happening in your programs when you run them, maybe a little bit more. I think it's the right time to just take a look at that for processing. We'll then introduce 2 concepts which you might initially struggle with, but I'm just going to introduce them today. One is overloading and the other is recursion. Now, these are advanced topics. We'll see overloading throughout the semester. We probably won't see recursion that much, but it isn't used that much. But we do need to mention it as we're talking about methods. And then finally, we'll move on to strings. So I'll just ask if there's any questions. You might pop those into Slack and we'll get started. Okay. I see people are still joining us. No questions yet, though. That's fine. Okay, so we'll start with more about writing methods. We're going to recap our eyes. Let's start there. So this was the example that I asked you to look at after class. So what we're trying to do is draw an eye on the screen. We create the size of the output window, 100 by 100, no stroke, so there's no border around the circles we're about to draw. Very simple stuff. We've seen all that before. In our draw method, we have background and a fill. So the background clears the screen. It's given it a grey color. We have a fill, setting it to black, and then we draw a circle. Here I'm using the ellipse method to draw a circle by specifying the width and the height of the circle being 60. So this is going to draw the outer white circle. And then we have a second one, which is the black circle. And then we have the third one, which is the small white circle inside. So if you look at this eye, it's an outer white circle, it's a black circle, and it's a white circle inside. So there shouldn't be anything there that causes any trouble. Obviously, the order is important that you draw these. If you draw the small one first, then it's going to be overwritten by the bigger ones. So the order is really all that's important there. And there's nothing there that should tax you at all. Okay, so that's stuff we would have done last week in Draw. And then in the last class, what we did was we said, okay, could we take the code that was in Draw and move it into its own method? And then call that method. So here we're saying I, a method called I, and we're passing in the X and Y position that we want to draw the eye at. So that's going to draw the first eye. And then the second one draws the second eye at a different position. And this is the output up here, so we can see what's happening. So all we did was we took what was in the draw method and we put it in here. So it's drawing the eye. We've left the background in draw, just all the code that drew the circles. Okay. And to make this method more useful, we have this concept of parameters. And parameters are effectively local variables for the method, and we can initialize those variables in the call. So here is our method call, and we were passing the 65. Beg your pardon, 1 second. Just step back there. So the 65 is passed in and initializes the X value, and the 44 initializes the Y. And then everywhere where we have X and Y inside of the I method gets replaced with the 65 and the 44. Then when we call the second I, we're passing 20 into X and we're passing 50 into Y. And again, wherever we have X and Y, they then get replaced with those 20 and 50. Okay. So it's not a big stretch then to move from drawing 2 eyes to drawing 6 eyes. We just have 6 calls to the eye method. And we're just passing in different x and y values each time. The eye method stays the same, the setup stays the same, just more calls to eye. So nothing too difficult there, hopefully. So what I want to do at this stage is I want to then show you how you might use loops to, instead of having hard-coded numbers for our x and y values, I'm going to see, could I replace those hard-coded numbers with loop counter variables? And here's a for loop inside a for loop. Okay, so what we're going to do is we're going to try and draw this picture on the right-hand side. And the picture has 3 rows, 1, 2, and 3. And on each row there are 5 columns, or 5 eyes on each row. 1, 2, 3, 4, 5. Okay, so let's take a look at this code here. And we'll run it and see it in a second as well. Okay, so in our draw routine, we have background, changing it to grey as before. And then I've got a for loop, and then a for loop inside it. And inside of that, I'm calling the method I. So I is going to pass in, it needs to know an x value and it needs to know a y value. So what's the x value and what's the y value? Well, what I'm doing here is I'm trying to come up with a number to specify the x position. And what I'm saying here is it's count multiplied by 60. And in this one, it's the row multiplied by 70. But what is count and what is row? Okay, so count is a loop counter variable. Starts at 1 and it goes to 5. We're incrementing count every time we go around the loop. So what we would see then, our values for count would be 1, 2, 1, 2, 3, 4, and 5. So 1 times 60 is 60. 2 times 60, 120. 3 times 60, 180. 4 times 60, 240. And 5 times 60, 300. So they're the values that row is going to, or sorry, count is going to have. So that's going to be our x value that we pass into the method I. And we also have this row variable. And row is handled by the outer loop. It's going from 1 to 3. So row is going to have the values 1, 2, and 3. So if we go 1 times 70, that's going to be 70. 2 times 70, 140. 3 times 70, 210. Okay. So the final part of this is to see what's actually happening. So the code is going to run. Row is going to be set to 1. Then we come inside the inner loop and we count from 1 to 5. So we're going to end up with 60, 120, 180, 240, and 300 when row is just 1. Then it's going to exit out of the inner loop, go back up to the outer loop, and increment row to 2. Come back down, and it's going to run the inner loop 5 times again. So we're going to see 60, 140, 120, 140, 180, 140, 240, 140, and 300, 140. The 140 being the value of row. That stage, you'll exit the inner loop, go back up to the outer loop. Row becomes 3, comes back into the inner loop, starting at 1, and counts up to 5. So we'll see the X value being 60, 120, 180, 240, and 300 for the row being 3. So we end up with effectively 15 I calls to the I method. And hopefully you can see those values. Okay, so could you, question coming in, could we switch the row with the count line or not? Yeah, we'll demonstrate that in a second. I'm going to run it in processing, and we can chop and change the code and you can see the output. Okay, we'll look at that in a second. So maybe I'll just switch over to processing at this stage, and we'll take a look at that. So just give me 1 second while I get this one up. And I might share this source code with you. I'll share it in Slack, and you can experiment with it yourselves then with me. Okay. So I've just posted iGrid into Slack. You can copy and paste or save that code, and then you can run it yourselves in processing with me. Where are we gone? Okay. Okay, I think we're just about there. Let's switch to here. Okay, so just for the moment, I'm just going to comment out some of this. Yeah, I know it's just the last two pieces. I'll just comment these out for the moment, and we'll come back to these later. Yeah, okay, we'll just focus on the first three methods. So our setup we're familiar with. Our draw is what I've just gone through on screen, and it's calling the I, which is what we had from the previous examples. So haven't coded anything different there. This is the only thing that's new. Okay, so if I run this, it outputs as expected 3 rows with 5 I's on each row. Okay, so we've got a 5x3 grid. Okay, so first question that came up there was, could we switch the row with the count line or not? So let's try it. Let's take this line. You want to take that out. You want to put it in here instead. You want to take this one and put it up here instead. Okay, and let's run it. Gives you the exact same thing. Okay. So the point is that the loops, what they're actually doing is changing the values of count and row. And it will then use the values of count and row in our call to I by passing in a calculation based on the count and the row. So it doesn't matter which order we call them in this case. It's just the order that they will be drawn in will be different. And because we are just seeing the thing drawn really quickly, it doesn't matter because it draws it so quickly we don't distinguish each eye being drawn. Okay. Again, that little trick I showed you the last day, when you make a change to your code, you can see this is all indented incorrectly now. So I'm going to edit and auto format, and that will tidy up everything. Using the auto format will help you identify some logic errors and some syntax errors as well. Okay, that's you're happy with that answer. Okay, cool. Okay, so what I'm going to do next is demonstrate our debugger. So before I demonstrate, let's just take a look here. And we'll just cover what you're about to see, and then we'll demonstrate what's actually happening. And hopefully you can do this with me. So we have, let's debug in processing. So in your processing window, up in the top right-hand corner, this button up here, okay, is the debugger. It looks like a little caterpillar, okay? And this is the debug button. And I think it's about time we took a look at that. So that's what I'm referring to, the debug button in processing. So if you click on this, turn on the debugger, you see it changes color. You'll get some additional buttons now in your processing interface. And we'll go through what each of these are. You'll also get this pop-up window, which has name and value, and the title of the window is variables. So what this will allow you to do is to see what the current value is of any variable at any given time in your program. I'm going to show you how to do that. And this saves you having to put lots of print line statements in your code to see what the value of a variable is. So how do we make this function? So what we do is we toggle a breakpoint. So a breakpoint is a place in your code where you want the program to stop running and pause. And then when it pauses there, any variables that are in memory will be populated in this window up here, and we'll see the current values of them. So this is very useful, particularly if you're finding it difficult to understand what's happening with loops, and even more so with nested loops. It makes it a bit easier to track what's going on. So if you click on the line number turns into a diamond, and the diamond is a breakpoint. Okay. So next then we can click continue. So I did mention we have these buttons up here. So this one here is the, this one is the continue button. Here it is. So if we click on continue, it will run the code. And when it gets to this line of code, whenever in the order of running all the different lines of code, it will stop when it gets to that point. And you can see in our example, it tells me that row has a value of 1 and count has a value of 1. Now I didn't have to do anything to get those, just by putting the breakpoint in and running to that line, it tells me what the values are. Also has a folder called processing, and if you expand that, you'll actually see that it has all the system variables that we mentioned in week 1, or was it week 2? Week 2, I think. And you can see what the current value of all the system variables are by just expanding that. Next we have step into. So if I click on step into, it's going to run this line of code, and what we'll see is it'll pause again, and we are now seeing that the values have been updated. So it's basically gone round the loop one more time, and in doing so incremented the count. Okay, so that's it. That's debugging in processing. And I would like you to have a go at this. So if you would take the code that I've given you in Slack, open up that code. I want you to put a break on line 18. And then I want you to follow these instructions, please. Okay. So turn on the debugger, set the breakpoint on line 18, and then I want you to click continue, which will get the program to run to that point. And then I want you to hit step into and repeatedly hit step into, watching this window here. And this will really make it clear what's happening when you have a loop inside a loop. I think this will make life very easy. Okay, so can you try that out for me, please? Just give me a minute or so to do that. Okay. And if you're stuck or have any questions, please post. Okay. Suppose it would have been easier if I demonstrated it in processing as well, wouldn't it? We might do that. So I'm going to turn on the debugger. Gives me this pop-up. I'm going to toggle a breakpoint at line 18 where it calls the I method. I'm then going to click continue. You see when you mouse over the buttons, it tells you what each button is. So clicking on continue. And it's run the program. It's showing me the display window and it's showing me the values of row and count variables. And if I expand here, we can see the width and the height, what values they have. You can see all these other system variables, mouse X and Y, P mouse XY, key and key code, key pressed, focused, frame rate, and frame count. So what we want to do next now is to step into my code. So I'm pressing step and then step. And if you keep your eye on the code, you'll see that it's showing you the current line of code that's executing, was highlighted in light blue. So at this point, I've hit step twice and my count variable has now gone to 2. I'm going to go again. So that brings it back up to the loop. It runs the inner loop, changing count to 3 and calls I. I'm just stepping, then it changes it to 4, comes back up, changes to 5, comes back up. So at this stage, when we run the inner for loop, count is going to fail. And it goes back up to the outer loop. Notice that in the output window, I no longer have row and count, I only have row. And that was because the count variable was local to the block for. So when that for loop exits, the count variable is removed from memory. It's no longer needed. So we're back in the outer loop. I'm going to step again. And now row is set to 2. And when row is 2, we're now going to run the inner loop 5 times. So count now is created, set to 1, then 2, then 3, then 4, then 5. Okay, so you can see that the value changing up here. And just to finish that out, back up to the top. So row is now 3. And then we can count through 1, 2, 3, 4, 5. Okay. Okay, so some of you are having a bit of trouble with that. Let's see. Cannot see the info from the debug. Okay, so if you run your code by pressing the run button, it's not going to do anything for you. So what we need to do, just go through the steps again. So stop what you're doing. Okay, stop. Turn on the debug. Yeah, so the reason that you're not seeing anything was when you click on the line, you have to click on the line number. So you see the way the number changes to a diamond here. I'll try and make that clearer on screen. So I'm right here. I'll zoom that up. So it's not good enough to just click on the line. You have to click on the line number. And when you click on the line number, you'll see it changes to a diamond. So now if you step, it should work for you fine. Okay. And of course, you can apply the debugger to any of the programs you've already written, particularly the ones that you're not sure about what's happening. This would be a cool way of seeing what's going on. One thing I would say is it's a pretty basic debugger. You can see the values of the variables. Where it falls down is you don't see the output window updating properly, but you can get a sense of what's going on with the code. Okay. Okay. So that's great. Hopefully that's all okay, and you've all managed to work that one out. Any other questions on debugger? Okay. So if you do have any questions on the debugging, you might just pop it in there. If you can't get it working, just let us know, and we can give you some help. Okay, so in this example, we've got the background, the eye, and we also had the draw method that we've now gone back over nested loops there, and hopefully you're okay with all of that. So I'm going to show you another piece of code. Again, we've seen last week how to handle mouse events, and we've seen how to define our own methods. So I'm going to highlight this bit here. So I'm going to handle the mouse clicked event, and because I already have a draw method, it means that we can have and pick up mouse events. So we're going to pick up when the mouse is clicked. And when the mouse is clicked, I'm going to say, call some method that I'm going to come up with myself, and it's called save my display. So when I click the mouse, it's going to call this method. This method is the method call. This is the method definition. We seem to have a little wobble there in our transmission. Everything back okay? Yeah, okay. I have no answers, guys. I don't know what that was. Okay. I was just about to start hacking in to see what was going on, but we came back pretty quick there. So let's come back to here. So I'll start from here again. So I have mouse clicked. I want to call some method that I'm going to make up myself. And I've called it save my display in all formats. So I've defined a method that returns no value. It's called save my display in all formats. It has no parameters. And I'm just going to execute some lines of code when I do that. So the line of code I want to execute is I'm going to save what the output is. So I'm saving igrade.png, and what this is going to do is it's going to take the output window, make an image out of it, and save it in the file called igrade.png. Okay, so I think we've gotten to the bottom of what the freezing was happening. So if you are watching and your stream is freezing, just if you watch it in YouTube rather than directly on the site, um, you should have better results there. Okay, I think it may be that our web host may be experiencing some outages or something. Okay, we'll see if we can play on. Okay, so we're going to save the output of our program, which is this window, and we'll turn off the debugger this time. Just run the program, and what we're trying to do is to get this picture that we've created, and I want that into an image file. And processing has a built-in method called save, and you specify the file name, and it can handle a number of different file extensions, one of them being PNG, which creates an optimized image file. So this is going to run when I click the mouse. So if I click on the mouse here, okay, it's not giving me any feedback, but what's actually happening is it's creating a file for me. And you can see it's just created that file. Maybe you can't. Let's try and make that a bit easier to see. So I've clicked the mouse. You can see what time it is right now, 12:55, and it's created the igrid.png file. So this is a really cool way of taking the programs that you're writing to create nice images and then saving them in code. So if I double click on this, you can see this is just an image file, and we can see that we can use that as an image. Okay. Okay, folks. So we've gone through the debugger, and we've also seen how to handle mouse events and how to do a save to save an image. So let's look at that again. We have the mouse clicked. I called my own method, and then in that method, I can define what I want to have happen. So I've just shown you how to save an image as a PNG. And then I've also saved it in JPEG, TIFF, and Targa. All of these are graphics file formats that are used in computing. And the difference between the first line and the second line, you'll see I've added a folder. Okay. And if we take a look at that, just copy this line. I'll just do it once so it's easier to see. So by putting in a folder name and a /, we can create the images in subfolders. So again, if I run that and click, and then so I've just added the img and the /, change the file extension to JPG. Then when I run it, click on the image, we can then see that in our output. It's now created. It's overwritten the original PNG file because the time is now changed. And we now have a subfolder called image, and inside there's a JPEG. JPEG looks the same, but if you compare the sizes, the file size 19K for the JPEG and just 5K for the PNG. And we'll just finish that out so you can see why we have different file types. So if we change that to TGA, and let's create another one. This time we'll do TIFF. Run it again. Click to generate the files, and then we can take a look at the files that are created. So we have TIFF file, which is an uncompressed image. It's 481 kilobytes in size. We have Targa, which is 32 kilobytes in size, considerably smaller. JPEG is almost half that. And then the PNG is a quarter of that again. So PNG, very efficient way of storing your graphics. And if you compared each of those files by opening them up, you'd be hard pressed to actually notice the difference between any of them. They all look very, very similar. Okay. Okay. Okay, so saving files okay? Any questions on saving the files? These are the four file formats that are supported, by the way. Okay, PNG, JPEG, Targa, and TIFF. Okay, seems to be okay. Right, so we spent a long time looking at the eyes there. We also had the X's that you did before class. So I'm not going to spend so much time on this one. Just you might remember we had originally how would you draw an X, and this was in the draw method. We had 4 lines of code for each X. So we had a grey X, a black X, and a white X. We then looked at different versions of that by moving out the code that draws the lines for the X into its own draw X method. And we parameterized it by allowing you to pass in the color in grey, the weight, how thick it was, the X and Y coordinates, and the size. And then all we were doing inside the method is using these variables, these local variables, in our calls to draw the lines and the colors and so on. So shouldn't be any real issue there. Okay. Main point is when we're using methods, that when you have parameters, and you call the method, so we're calling draw X, the 0 here is going into grey, and the 30 is going into weight, the 40 is going into the X, the 30 into the Y, and the 36 into size. So we're passing values from a method call into the method definition. The method definition has these parameters or arguments, is another word you might hear. And effectively each one of these is a data type and the name of the local variable that's going to be used in the method. We can then use those local variables, arguments, or parameters, whichever term you prefer, inside the definition of the method. Okay, so this one has 5 parameters. Okay, and that was to draw a single X, and then the example that we finished on was drawing 3 X's. So you have a thick grey one, a medium black one, and a thin white one, and they're in different positions, and this is how we would call it. Okay, right. So the examples that we've seen up to now, this is all just a recap up to now. Okay, going back over old ground. And everything we've looked at is, sorry, I'm just keeping my eye on the messages here. Everything that we've looked at up to now in the methods is returning no value. So they were all void, nice and simple. And what we want to spend some time at now is looking at, okay, how can we return a value from a method? Okay. So we're going to look at, first example is converting Celsius to Fahrenheit. Okay, so let's get into that. So the previous two method examples didn't return a value, so the return type was void. And now we're going to look at an example where the method does return a value, and it could be any data type. But in this next example, we're going to return a float. Okay. So we have Fahrenheit to Celsius is what we're trying to do. We have a setup method. We declare Celsius to be a float variable. So this means it's a decimal number. And we're going to say Celsius gets the new value calling Fahrenheit to Celsius. This is our converter method that we're going to write. I'm going to pass in 451.0. So we need to write a method that can accept 451.0. It's going to take that number in. It's going to convert it. That's the Fahrenheit number. We're going to do some equation to convert it into Celsius and then return the value back to here. And then the next line will print out what that value is. Okay. So here's the definition. We have Fahrenheit to Celsius. It returns a float. It takes in a float, which is the Fahrenheit value. It's returning the Celsius as a float value. So you don't have to worry about remembering how do you do that calculation. You can look that up anywhere. It's Fahrenheit value minus 32. When you get that answer, you multiply it by 5/9. And we're storing that in result, and then we can return result. So let's work through this. The 451 is passed into the local parameter variable Fahrenheit. So we now have 451 stored in Fahrenheit. That 451 for Fahrenheit is used anywhere where Fahrenheit is used inside the method. So if we substitute 451 for the word Fahrenheit here, we get 451 minus 32 multiplied by 5/9. So if you do that calculation, it works out to be 232.7779. So that answer is now stored in the variable result. And we return result. So this is a new keyword. Return, okay, is a new keyword. And anytime we want to return a value from a method, we have to use the return keyword. So we're returning the result, and we know that result has 232.7779 stored in it. So that answer, that number, gets now stored in the variable Celsius. So Celsius is now 232.7779. So what we've introduced here is the concept of a return type that's not void. In this example, we're using float to return a decimal number. We've seen how to calculate the numbers, and the important thing here is we're using the return keyword to return the value from a method back to the calling method. Once that number goes back, we can then use that value. It's now stored in Celsius. So just as before, that number will be used in the print statement. We've seen how to print out the value of a variable. So we'll get the number printed out on the console. Okay. Now, we can take a shortcut. And the shortcut here is, instead of declaring the variable result in the method, we could just remove that need to declare the local variable, and we could just say return and then use the equation. Okay, so effectively what I'm saying is what's in green here could be removed, and we could combine the two lines into a single line of code. Don't have to, but they both do the same thing. And whichever one you're more comfortable using is the right one for you to use. Okay. Might just see how you're getting on. So which of these would you prefer, the top or the bottom? Okay, give me a thumbs up for top. Our bottom is down, thumbs down. Okay, in Slack. Okay, seems like most of you prefer the bottom solution. Okay, I have to say that's kind of goes against the grain normally. Most people normally prefer the top one, but if you prefer the second one, that's perfectly fine. Happy days. It is more efficient, okay? It reads easier, and it takes up less memory. Okay, so I think the bottom one is the way to go then. Okay, cool. Okay, so next up we have cubed. Again, this example and the next one are ones I've added to the slides since the start of the week. So you may need to download these slides again if you want to have these in your notes. Okay. So let's take a look at what's happening here. We've got setup. We've got a size, text size, and a fill. Nothing new there really. The fill is RGB value, so it's setting the fill to blue, and that's why we've got the blue text up here in the output. In my draw method, I've declared a number which is of type integer. We've initialized it to be 5, and then I'm calling the text method. You might remember that from week 1, which allows us to output a message onto the display. Okay, instead of putting it to the console where the end user, we need to make this point clear, you can write a program that outputs stuff to the console, but the end user would never see it. So if you want the end user to see it, it needs to be on the display window. And to do that, instead of using print line, you use text. Okay, so generally speaking, we'll be using print line just for the programmer to get a message. But if you want the end user of your program to see any output, you should be using text. So text takes in a string. So in this example, my string is all of this. And we've seen examples like this before. We're saying the value of the variable number. So in this case, that would be 5. And that's appended to the string cubed is. So we're now saying 5 cubed is. And then we're calling a method cubed and passing in the number 5. And whatever that answer works out to be, that's what will get added onto the string. Now 5 cubed is 5 multiplied by 5 multiplied by 5. So that would be 125. So you can see in the output, we've got 5 cubed is 125. The numbers here, okay, is the X and the Y value for where the text is to be positioned. Okay. And the point here really is this is an example of where we're calling a method called cubed. So cubed this is where it's defined. It takes in a number. So the 5 comes into number. And then that number is used to calculate the return value. And from our last question, most of you said you preferred using just return with the calculation because it's a nice simple one. And here we've got another simple one. It's number multiplied by num multiplied by num, and that just gets returned. And then that return statement is going to return the value back up to cubed. Okay, so again, we've got a return type of int. In this case, we're taking in a number, which is an integer. The 5 is passed down. Then everywhere where we have number gets substituted for the 5. We can then do the calculation. 5 by 5 is 25. 5 25s is 125. So 125 gets passed up to the caller. In this case, it was cubed 5. Okay. So any questions about cubed before I move on? So again, if you have questions, you can just reply to cubed OK. Give me a thumbs up if it's all right. If you're not sure, give me a thumbs down. Okay. And we can follow up with that later. Okay, I think that seems to be good. So let's take a look at product. This is a very similar example. I'll just get out of the way for a sec. So in this example, setup is similar to the previous one, except this time I've changed the text color that I'm outputting. I'm mixing RG and B, so I'm mixing red and blue to create this kind of pink color. Then we've got the draw method. What's different in this example, we've got A and B, they're now decimal values. And again, we're just outputting a simple message to the screen, just as we did before. We're saying the product of A and B is, and then call this method product AB. And product AB is the call, and the definition is down here. So we've got a new product definition. It takes in two numbers, a float num1 and a float num2. So inside of this, we only refer to num1 and num2. Even though I'm passing in A and B, these are the local variables. The A, whatever the current value of A is, gets passed into num1. Whatever the current value of B gets passed into num2. And then we no longer talk about A and B. Okay, it's now a localized issue of working out the product being num1 multiplied by number 2, and then pass it back. Okay, so again, what's different about this example is we're returning a float rather than an int or void, and we're taking in two parameters which are also float values, num1 and num2. Okay, I think that one was all right. That's just another example, very similar to cubed. It shouldn't have caused, shouldn't be really causing any trouble. Okay, I think we'll take a breather at this stage and just give you a couple of minutes to yourself. And we're going to take 2 breaks today, so I'm going to shorten the breaks, but we'll give you 2, okay? So let's get that up on the clock. Okay, so we'll talk to you again in 5 minutes' time. Okay, welcome back. Short break there. We'll give you another break before the end. Just need to break up. We've a lot of materials today, so just need to break it up a little bit. Okay. Just before we continue, so I've just posted in Slack there that if you are having trouble with the live stream through tutors today, it may be because the tutors web server is under a bit of pressure. So if you prefer, you should go to the YouTube and watch the link directly in YouTube instead. Okay. And if any of you are actually watching, you might just post in the link to today's class there if you wish. Okay, so we'll get going again. Just give me a sec. Where are we? So what we're going to look at next is two terms, overloading and recursion. So let's start with overloading first. Okay. So here's where we are in our list of things that we're going through. Overloading, okay? Multiple methods can have the same name once they have a different parameter list. In the previous examples, we've seen, for example, when we were drawing the x's, that you could call draw x with no parameters, with a single parameter, 2 parameters, 5 parameters. And what we're saying is when we talk about overloaded methods, this is what we're referring to. In this case, draw x is an overloaded method. Draw x is a method because there were multiple versions of it to handle different numbers of parameters. We call that an overloaded method. Okay, so we have the same name, but the parameter list is different. Now, it's not just a quantity of parameters. You could have, for example, another draw x here that might take in 2 floats. So it's the number and type that's different. So if we compare those examples, we can see in our parameter list on the right, the first one has no parameters, second one has an int, the next one has int and int, and then the last one had 5 ints. Same method name, but a different parameter list. So a program can have 2 or more methods with the same name, only if their parameter list is different. When Java is checking that a parameter list is different, it's not checking the name of the variables, it's checking the data type of the variables. For example, this is permitted as the data type is different. First example here, we've void draw x int gray, and the second one, void draw x float gray. So even though we have the same name for the parameter, the data type is different. And even though both of these examples have one parameter, the data type is what's different. Okay. Data types must be different for a method with the same name for it to be overloaded. So which draw x method is called and why? So I'm going to leave that as a question here and see if you can answer that one. And I'm doing this in Slack. So on the right hand side, you can see 2 draw x methods. One takes in int gray, Second one takes in float gray. We're making a call to draw x by calling draw x 0. So does it call the top one or the bottom one? And why? Okay, so it seems to be a bit of confusion here. It can only call one of them. Okay, and it's looking at the parameter list. It's looking at the data type. It's comparing the number that's been passed in. The number that you're passing it in, does it match int better or does it match float better? Because it's only going to pick one. It can't pick either one. It can only pick one. It has to run one. And what we're trying to do is figure out which one it would run and why. Pennies dropping, yeah. So I delete the evidence there. I won't mention your name. Go up to the top and delete the evidence. Got it right first time. There you go. Likewise. Yeah. So I think you can see from the answers in Slack now, guys, that it's going to pick the int one because 0 is an int number. It has no decimal. Okay. If it was going to call the second one, the method call would have been draw x brackets 0.0, 0.0. Okay. So hopefully you can see that now, everybody. Okay. Thanks for your responses there. Okay. So it's always going to look at the values being passed in, and it's going to try match those values up with what's happening. What if it's got multiple overloaded methods, it's going to look at the parameter list and match them up as best it can. Okay, and in this example, it was the int, so the 0 is going to call the top one. Okay, thanks for that. So when you call a method, Java matches the number and the type of the arguments you pass to the method with all the declared methods. When a match is found, Java invokes the method. For example, draw 0 calls draw x int gray, which is the question we had on the previous slide. If it was going to call the float one, it would have been draw x 0.0. And then the unexpected answers that I got were it could call either one, or it could call both. And that would be incorrect. It can only call one method, and it's got to figure out which one to call so it matches up the data types. Okay. Any questions on that? So that's just a nice simple example of overloading. We are going to be overloading methods for the remainder of the semester. So don't worry if it doesn't sink in straight away. We're going to be spending a lot of time overloading methods. Okay. So next up, we're going to take a look at recursion. I'm doing this for completeness. Most people will not write code with recursion. It's not the preferred way of doing things. Sometimes it makes problems simpler to solve, but generally speaking, we tend not to write our code for recursion. Okay, so let's take a look at recursion. Okay. So what we've got here is an example where we want to draw 4 lines. Okay. So in our setup, we're setting the output window to 100, 100. It creates that gray box. And then we're calling draw lines. The length of the line is 10. I got that at the start. Yeah, it starts at 10, and then we want to draw 4 lines. So the 4 is the number of lines. Okay. So again, just to point out, so the 10 is passed in here, and the 4 is passed in here. So xstart and numLines are the parameters that are being used in the drawLines method that we're now going to define here. We have a for loop. The for loop is counting from 0. Keep going while I is less than the number of lines. And I'm using numLines minus minus to decrement the number of lines. Okay. Remember, number of lines we said was 4 initially. So we're going initially for I is less than 4. So we're counting 4, 3, 2, 1. And that's the way we're going to count. Now, what do we do every time around the loop? Well, we draw a line. This is where we draw the line. And xstart plus equals 5. Instead of incrementing the loop counter variable I as normal, the condition is being reduced back to 0 by decrementing number of lines. So this is something we've seen before. Now we're going to introduce recursion. A method can contain a line of code that calls itself. This is how we define recursion. A method can contain a line of code that calls that method. To stop the infinite calling of the method, it's necessary to have some way for the method to exit. This is called a base case, and you continually work towards a base case. So let's look at the same problem again, but this time with recursion. Our initial setup is the same. The output is going to be the same, but the way we implement draw lines is going to be very much different to using the for loop. So what we're doing is we're calling draw lines. The 10 matches up with the x, the 4 matches up with the num, and we draw this line. And then we have a base case. The base case says, is your number greater than 1? Num, remember, is one of the local values passed in. So if the number is greater than 1, what's going to happen is it calls draw lines again. So look at this. We're trying to write the method draw lines, and in trying to write that method, we're calling draw lines. So that's like defining something in terms of itself. So kind of it's not the usual way we go about answering questions. You know, it's if somebody said to you, what's a car? And you say, well, a car is really a car. It's confusing. And likewise, when we come to coding in recursion in programming, recursion can cause some trouble. It's not quite as bad as I just described. We have draw lines as the method. We called it initially with 10 and 4. And then inside the method, you don't call it with 10 and 4 again. What you're doing is you're changing the number. So you're saying number is decremented by 1. And it's going to call itself again. So it calls it with 10, 4. Then it's going to call it with 10, 3, 10, 2, 10, 1. And when it comes in at 10, 1, it says, is the number greater than 1? No, it's not. If it's not, then that's the exit case. And then it rewinds back. So don't worry if you don't get this first time round. I'm just going to show it to you today and you can revisit it another time. Let's take a look at it. So we have successive method calls with our recursive example. So we call draw lines with 10, 4, and it draws a single line. So you can see the output down at the bottom here. So x is 10 and number is 4. Therefore, number is greater than 1. So it's going to call draw lines with 15, 3. So it draws the second line and it tests again. X is 15, number is 3, still greater than 1, so it's going to call draw lines again, this time with 20 and 2. First thing it does is draws the third line. X is 20, number is 2, so number is still greater than 1, so it's going to call draw lines again. So it draws the fourth line. But this time, X is now 25, number is 1, which is not greater than 1, so therefore we exit. We have our exit or base case. So the base case is met. So now what happens is we, having reached the base case, return back to the call, back up the call stack to the original call. So we just basically finish out all our calls. So what I'd ask you to do maybe is to run this example through your debugger tonight. We've shown you how to use the debugger, and that might help you see exactly what's going on. This slide is quite useful as well. Okay. And that is recursion. Okay, so I'm not going to dwell too much on it because that can be quite a chunk to take for the first time. Don't worry about it. We won't be using it a whole lot. We actually won't be using it at all for the remainder of the semester, but I'm showing to you for completeness, okay? And what I'll do at this stage is just mention that while I haven't been stopping to do lots of questions during the class, I did announce that we've got a room now for each quiz. So I've got a quiz for today's class, and I'll make that available now, I think, in Socrative. The room is Prog OD 3B. Okay, so our quiz is in room Prog OD 3B. ProGod 3B. Okay. And I'm going to take a breather at this stage. We'll take another 5 minutes and then we'll come back and wind up the class. Okay. Okay, folks, welcome back. Last part of today's class, we're going to look at strings in Java. Okay, right. So here's what we're going to be looking at. We talk about strings. We first have to talk about characters. Okay, a character is a single character, and in Java they're special. They use something called a Unicode system, which we look at in a second. Also, all of the data types we looked at up to now are called primitive data types. And in order to use strings, we have to introduce object types. And we'll spend the whole semester working on objects, but we're just introducing it today, okay, using an object. We'll be defining our own objects, but we're not getting into any of that just yet. We just want to be able to use strings. So today's talk is about just showing you what's available with strings so you can call methods to work on strings and manipulate text. Okay, that's really what I want to get through today. But we have to look at some terminology behind that. So we have the difference between primitive types and object types, values and references really. We also have strings in the Java API. So we're going to look at the Java API as a whole library, application programming interface, a whole library of methods that you can call. So you have to know what an object is, string object, and then we can look at what methods are available to us. And we'll just show you what's available and then you can use them. We'll also then look at how we call methods, both internally and externally. And really what we're getting at here is something called dot notation for those of you that have looked at code before. And there's a lot of terminology here, but really we're going to try get to the bottom pretty quickly, skip over the terminology, not dwell too much on it, and actually just get to use what we want to use. So we'll be using the dot notation, and we'll look at finish up with some calls to string methods and see some examples of what you can do with the libraries. Okay, so we may not get through all of this, but let's see how we get on. So we're going to start with character. The Java programming language supports 8 primitive data types. These are byte, short, int, long, float, double, char, and boolean. We've seen all of these already. We've also seen the default values, and today we learned how actually putting in the correct default value might influence, for example, overloaded methods. You'll notice that the char one here looks a bit different to all the rest of them. Char and boolean look very different. So it's not just a character, it's single quotes and it's got a value inside it. And that value is a special code. It's a Unicode code indicated by the /u. The character data type stores only one single character, which is delimited by single quotes. For example, you can say char letter equals single quote A, or you could say character letter equals single quote with the Unicode code for the letter A. So here's some valid uses of a character. We have the letter char letter is assigned a value n in single quotes. This is fine. We then have char letter is assigned a value uppercase n in single quotes, and that's fine. Just getting a question there, just pause for a second. Apologies. Okay, I think we're okay now. Yep. So then we have the invalid use then of the characters. So we have char letter is assigned a value n, no single quotes, that's going to give you an error. If you use double quotes around the n, that turns it into a string. So that's, again, incorrect usage. And the final one where we have 3 characters together, again, that's a string, so it's not a valid use of the char data type. Char is a 16-bit Unicode character whose values range from 0 to 65,535. This is specified in hexadecimal. Again, we don't have to worry about any of this, but it's just here to show you. We have, for example, 0041 is how you would get capital A, and 0061 is how you get a lowercase a. So I've given you a link to the Unicode system, which we can take a look at as well. And here it is. So we have Unicode characters, and you can see that the range of values is split up into different languages. So for example, the Hebrew alphabet. If I wanted to be able to recreate symbols or characters from the Hebrew alphabet, I can, again, even though they're not on my keyboard, I can pick them up and pick out the Unicode number or the HTML code for it as well. Okay. And you can explore that in your own time. That's the Unicode character set. Okay. So here we've got an example then of using the Unicode character set and knowing about these numbers. We've got a loop going from 0 to 26 because there's 26 characters in our alphabet. And if we say that character is assigned a value uppercase A, and then we print out the letter, it's going to print out our letter A, and we're incrementing letter by 1 every time, so that's going to change the Unicode value by 1. So what this means is we can see the output of the whole alphabet. We're adding 1 to this code, and when we run it, we get the full alphabet written out without having to type it out. Okay. Of course, if we had initialized the letter A to be the lowercase a, then we would see the entire alphabet printed out in lowercase. Object type string. So strings, which are widely used in Java programming, are a sequence of characters enclosed by double quotes. For example, sequence of characters in double quotes. In Java, a string is an object type, and the Java platform provides the string class to create and manipulate strings. The most direct way to create a string is to write string greeting, assigned value, double quotes, and then put your string inside. These are valid uses. So we have, note, string is in uppercase. We have the variable name, assigned value. First case, it's I am a sentence. Second one is dog. Third one is a, all in double quotes. Where you go wrong is if you don't use the double quotes to initialize. Or you try assign a character to a string. Or in the final example here, if you use the lowercase s, because object types are defined and declared with an uppercase first letter. Remember we said Java is case sensitive, so this is one that might catch you out, so be aware of it, okay? Object data types start with a capital letter to distinguish them from primitive data types. So what's the difference between a primitive type and an object type? Well, primitive types is what we've been working with all along. So for example, int I, int is a primitive type. And when we say int I is assigned a value 17, 17 gets stored in a box in memory. With an object type, for example, hi is the variable, string is the object data type, and we're assigning the string hello in double quotes. We don't actually store the value hello in the variable hi. What we do is we store the string hello somewhere in memory. And somewhere in memory has a memory address, and that's its reference. So in this case, to highlight it, I've said ampersand FFCC. So this is a reference to the memory address where hello is stored. So when we say string hi is assigned a value hello, it puts hello somewhere in memory. It identifies where does that memory location start, and then it stores that memory location in the variable. So on the left-hand side, we're storing actual values, whereas on the right-hand side, with objects, we're storing references, not the values. So with primitive type variables, for example, int, float, char, etc., the value of the variable is stored in the memory location assigned to the variable. With object types, the variable holds the memory address of where the object is located, not the values inside the object. This memory address is called a reference to the object. Now, when I first started programming, when you started using strings, if you didn't use them correctly, because you were storing memory addresses, you could end up overwriting the memory of the operating system. So if you coded your program wrong, you had to turn off your computer and turn it back on again. And back then it used to take 5 minutes to reboot a computer. Luckily, we don't have that today. Our memory is protected. Our operating systems are better and they protect the memory. So if you get references wrong, you don't have to worry about it so much. Now that we know how primitive types and object types store data, we will look at the statement B is assigned value A in the context of primitive and object types. So if we say B is assigned a value A, and here's A is 17 in a box, it's a value in a box. And we want to say B is assigned a value A. B being an integer, we'll just make a copy of that value and store it likewise. So we have 17 in 2 memory locations. When we look at object types though, things are a little bit different. So again, A is a string, so it's a string object. They don't store values, they store references. So here, A is storing a reference to where hello is stored in memory. So when we say B is assigned a value A, where B is a string, in this case, instead of copying hello, what you're actually doing is you're copying the reference into the into B. The reference is stored rather than the value. So side by side, on top we see how B is assigned a value A works for object types, and on the bottom how it works for primitive types. Okay, now the point of doing that was to introduce strings. So I'm going to just get to the real value of what we've been looking at. Might just overrun by a couple of minutes, but I think it's important to keep going at this stage. So we're now going to look at what's the point of all of what we've just said. Well, variables created with the string data type are called objects, and objects are software structures that combine variables with methods that operate on those variables. Again, don't worry about this too much because we're going to be seeing this a lot in the coming weeks. But I want you to be able to use strings for your assignment that's coming up. So this link is to the Java's API version 8. We click on it and we share it with you. This is the all of the different libraries that you can call. Okay, and you'll never know them all. You'll learn about a few of them and we'll use some of them. So let's take a look at what we're actually going to use. So here is the string class defined in Java, and you can see some examples of how to use it. And we can also see that if we go to method, these are all of the different methods that we can call to work on strings. And again, there's a hell of a lot of them in there. Okay, so I'm just going to highlight a couple that you might find useful to use. Okay, so string methods. These are probably the most common ones. So you can call the length method to uppercase, to lowercase, trim, substring, and character at. Okay, so the length is how long it is. To lowercase will convert, if you have a string with mixed letters, it will just convert everything to lowercase. To uppercase does the opposite, makes everything uppercase. Trim will remove any leading and trailing spaces in a string. So you can remove any leading spaces. Very useful when you're doing things with passwords, for example. Substring finds a string within a string. And character at will return the index of a string, of a character within a string. Again, we'll be looking at this in the future. But I thought maybe lowercase, uppercase, length might be of use for what you're going to do in your assignments. So, method calls. Really what we're talking about here is dot notation. We have the distinction between internal and external methods. So we've been calling internal methods like drawX, passing in 0. And this is what we mean by internal, is the method is in the same file. And that's pretty much what we've been doing. We can call or invoke drawX. DrawX is a method call. Sketch has a method with the following signature. The method calls or invokes this method. And as the method is in the same sketch as the call, this is called an internal method. Again, I'm skipping over this because this is really jargon and terminology. What we want to get to is how do we call external ones. And here are the external ones. We want to check the length of this string, Joe Soap, so we would use the length method. A call to a method of another object is called an external method call. And to do that, we have to introduce dot notation. To find out the length of the string name Joe Soap, we use name dot length bracket bracket. So this is how you use it. So this is the object, we have a dot, and we have the method name. So if you want to use any of the string methods, you'll create a string object. In other words, a string variable, it will have some name, and then you'll use that name, dot, then the method name that you want to call. If it takes parameters, you can pass those inside the brackets. So we refer to that as dot notation. So it's the object name, the dot, the length is the method name, and then any parameters go inside the brackets. So finally, some examples. So here's an example of how you can find the length of, in this case, message, which is I wonder how long this message is. It's 33. So it's giving you back the answer 33 by calling message.length, where message is a string object. Here's another example where you can include that in a print statement. Here's where we might convert the message, I wonder how long this message is, so that it all appears in uppercase. And here's how we convert it to lowercase. So the capital I becomes a lower I. And here we've seen trim in use, so we can remove the leading spaces in the original one and the trailing spaces. And after you've done that, you end up with a shorter string. So you can get the length of the shorter string. Okay, so apologies for going 5 over there, but I thought it was important to keep going so you could see the purpose of it. When you split it out, it's it can be actually harder to return to it. Okay, so what we've done there is shown you strings. Okay, the reason I've shown you strings is there is one final part that's going to appear in your assignment that's coming up at the weekend. You have 2 weeks to do your assignment. I'm not releasing it until Sunday. Okay, and the reason for that is I want everybody to continue working on the classes, continue working on the exercises, and try get the first 3 weeks complete before you attempt the assignment. Now the assignment is specified in great detail, and I will present it to you on Sunday evening. Okay. So if you have any questions, you can post them in Slack. But otherwise, I've gone 5 over, so I better stop and leave it there. Okay. Remember, next week, no classes. So you'll be able to work on your assignment all next week. And then you have one more week when we do return to class, and you can, we'll be taking your questions. I think there'll be a lot of questions that week. We'll take them then. Okay. So keep up the good work. Keep plugging away. It should all start falling into place, I think, by next week. When you work on this assignment, it's really going to fall into place. Okay, folks, thanks very much. Cheers.